Okay, so I was thinking a lot about this problem that we just did with the in the last video. We basically did the resultant force of F1, F2, and F3 in this picture basically, and it came out to this in the end. And I just used my calculator really, and computed that real quick. So in the end, it's just that. So really the whole point of this video now is because a lot of times the question doesn't end there. The answer to the question is like for a lot of these physics questions are going to be like, oh, now what's the angle and the magnitude of that resultant force? So now we have to measure the angle, and typically the angle is just measured from the positive x-axis counterclockwise. So now this is like the same angle direction that you're used to with the unit circle. So in the end, um, you're going to use that angle. So like I said, you're going to have to find the angle and also the magnitude. So direction and magnitude in the end. Of course, the Cartesian vector right here does give you direction and magnitude, but it's a little it's a little bit in pieces. So anyways, so really, if we drew this, it would be like -1 down and like a lot in the negative direction over here. So in the end, FR is going to look like this. So and we have to essentially get this angle. So in the end, in order to get that angle, we're going to use inverse tangent. But before we do that, I just want to get the magnitude. So the magnitude's actually pretty easy. So the magnitude, we're just going to use the Pythagorean Theorem. And we're able to use the Pythagorean Theorem just because, whenever we deal with components, 90 degrees, if it's a right triangle, you can use a squared plus b squared equals c squared, a squared and then b squared, c squared, or, well, I guess a, b, and c, I could technically on there, but a squared plus b squared equals c squared, so is what I'm trying to say. So anyways, so if we want the magnitude or the length of this guy now, FR, we're going to have to just do the Pythagorean theorem of that. So the magnitude of FR, so that's just written like this with little lines on the outside. So not brackets, just straight lines. So so anyways, or usually it's double lines, but that's just because there's determinants and whatnot. But I'm just going to do single lines. So in physics, you do determinants, but not like, but a lot of people can tell from this is just going to be the magnitude. So anyways, that's just going to equal, so 12.3923 squared plus 1 squared, which is just 1. So then that's going to equal, so let's just go to our calculator, turn it on. I don't know why it goes off. It's a little mystery to me, but so second, it's going to do the square root, and then second answer, square that, and then plus 1 in the end, because 1 squared is just 1. So enter, and we get that. So which kind of makes sense, if this length is already 12, basically this is going to be 12 also. So, but it's going to be a little over. So that's just because the x dominates the y so much. So anyway, so our magnitude is just 12.4326. Okay, 4326. So, and that's just going to be in newtons then. So, okay, so now we're going to be on to the angle. So theta is just going to equal inverse tangent of basically it's going to be y over x, just because it's you know we're going to be doing opposite over adjacent inside of here. So and it just so happens to be the y is going to be the opposite and the adjacent is the x. So it's going to be negative 1 over negative 12.3923. Sneak that 3 in there. So anyways, so that's going to make this positive actually. And so the thing with inverse tangent, it only graphs its domain ranges. Well, I shouldn't use the word range when describing domain. The domain goes from negative 90 degrees to 90 degrees. So so really that's just going to be the fourth and first quadrant. So what happens when we're in the second or third? And for this case, we're actually in the third quadrant. So to counteract that, we're going to have to add 180 degrees. So that's just the rule with inverse tangent. So the rules with cosine and inverse cosine and inverse sine are way different. So you could probably use them in the end, but the easiest way is inverse tangent in the end. So so what we're going to have to do, since we're in the third quadrant, is add 180 degrees. So we're going to be working with degrees just because we're in physics. In physics mode right now, you know. So whenever you're taking your exam, you want to have your calculator in degrees for physics. But if you're in like a calculus or some other math class, you're going to want to use radians. So it's just kind of weird. So engineering and physics, degrees, math is going to be radians. Kind of weird as how it's split up like that, but make sure you're in the right mode for your exams and whatnot. So so yeah, so we're going to be adding 180 degrees in the end. So so the main reason is because tangent is positive in the first and third quadrant, so it almost like links those two. And then also tangent is negative in the fourth and second. So reason being is so we have a positive x direction and positive y direction for the first quadrant, but since it's like a y over x, if it's a negative over a negative, we get a positive in the end. You know, the negatives cancel out. So in the end, we want this angle. However, we're only given this little tiny angle, as you can see from right there. So so we want the big angle in the end. So so we're gonna have to add 180 degrees. So second and third quadrant always 180 degrees. So anyways, so so now go to our calculator. So press on. So second entry. So so yeah, as you can see, I did this wrong last time, but I'll be doing it right. So it's negative 1 divided by, so your answer, which is negative 12.39. So as you can see, the negatives cancel out, meaning it's necessary to add this, have this 180 degrees, you know. So so anyways, enter. So we get 4.61 degrees, I believe. Pull that back up again. And then we're going to have to add 180 degrees to that. So now our angle is simply 184.61 degrees. So now we have our magnitude, which is just this guy. And we also have our angle, which is just this guy right here. So typically, this is how your answer is going to result. You know, that's how it's going to end up as just the magnitude and the angle. So that's just the extra step. It's just another way to describe the vector in the end. So what this is really called is just the polar coordinates. You know, you have your r, your radius, and then your angle, theta, and it's measured from the usual spot. You know, so from the unit circle.